And that's what I would then call CGMMV. Without all of this together, I will not call and be confirmed that I have CGMMV in that sample. This year, it can take a week and a half to 2 weeks to get the answer. This one here is a different formal test that allows us to quickly do our testing based upon an assay that they say is very specific to CGMMV, and you get to know the result basically on that day. However, we're finding that it's not detecting all of the samples, depending on what it is. This is what they've been using to try to improve the seed testing, but it's not doing too well because some of the cucurbit seeds, like the pumpkins, for example, the seeds are quite large. How would you test 95,400 seeds of very large seeds? So then they're hitting some problems with some of that. Another form of testing is what they call ELISA, using antibodies, where you get a colour change, yes or no, you get positive or negative. This one here is a little bit, takes 1 to 2 days depending on how many samples you have. The longest one is that all of these tests gives you a yes, no positive, yes, no, the virus is there. It doesn't actually tell you the virus is alive or it's a dead piece of virus. The only way you know for sure if it's a live virus is you inoculate cucurbit plants. So this is what we call plant assays. You actually take a young seedling, rub a piece of sap of your positive material, and about 7 days later you start seeing symptoms. So this symptoms here is actually about 4 weeks into the bioassay trial. Each bioassay trial takes 2 months to do from start to finish, including testing. So this is a part of work that Dr. Fiona Constable is conducting in Melbourne. So her lab actually looks at and tests seeds that come to water, as well as intercepts on seeds and just do testing. So it started back to 2015. So basically from October 2014 to May 2015, they tested over 200 samples of seed submissions. All were tested on ELISA, using ELISA, but only one of those submissions was positive. So we have the case of, are they really negative, or is ELISA not sensitive enough? So that's why there's a push for more sensitive testing to be done. So the question here, and I think which is really important, is are they pre-screening and excluding contaminated seed? Or do we need, or can we rely on internationally accredited seed testing labs? Or do we put in the requirements that they actually have to be tested in Australia itself? So at the border, in 2014, the testing increased from 2,000 to 9,400 seeds, which is basically 20% of the batch using ELISA. With a maximum seed sample can only be 100 seeds, so they have to do that 94 times in that plate in the soil. They did in 2016 or last year, they tried to do the same scenario, same numbers using that quick assay. I'm going to show you that it's in real time. You can get the results within that same day. It's a reliable test, however, there's still some optimization work to be done. They're still having problems with the extractions, as I mentioned. The difference between the size of the cucurbit seed is actually problematic to the extractions. Or what they did find when they were doing all this is at that, when this all started in Australia, there was no records that pumpkin seeds actually have the viruses. So everyone was talking about watermelons, but what's happening to the pumpkins? So at that particular time, cucurbita and Shata and Maxima were not even on the list to be restricted. It is now, because we have Fiona's labs been able to find that it does contain CGMMV.
So those two are pumpkins, just the people?
Yes. They're just hybrids of pumpkins and squash. So even to this day, as I mentioned to you before, even if you find your virus as a positive result, this question still remains of, is it live or is it dead? So to check if it's live, you have to do the live assays. But in the seed case scenario, they don't care if it's live or not. They won't take the risk. So if they get a positive result from the seed batch, that seed batch is destroyed or rejected. So it stops right there. When it picks up, it gets stopped right there. So the research. So following the detection in the Northern Territory, we had a discussion on a national level with industry. What are the research gaps? What didn't we know about CGMMV research around the world? What were the things that still was learning from our growers? So the first question was, how long does the virus survive in the soil? Does soil composition and temperature play a role? Because in Israel they found that soil composition did play a role, soil temperature did play a role. Anything above 50 degrees for several months was able to kill the virus. But their environment is very different from ours. Their soil composition is very different from us. So at that particular time, some of our growers or some of our properties were 8 to 12 months with no cucurbit hosts. So as Greg mentioned, when they were placed in the quarantine, there was strict guidelines that they could no longer grow cucurbit for 2 years. So at that particular time, we didn't know. We just have this information from a researcher overseas that he found to be still in the soil, alive after 6 months, at least 6 months, but we didn't have a definitive date. So the Northern Territory Government gave us funding for a small project to answer these questions. And at the same time, the burning question was, do honeybees play a role in this whole scenario? Because at that particular point, literature said honeybees, there was no known vectors for this virus, insect vectors. So again, back to seeds. We know that cucurbits can have contaminated seeds that can carry on an infection. But the same scenario go for weeds, we didn't know at that particular time. So if the weeds play as a native host for this virus, does it go through the process, go through the plant into the seeds and able to be dispersed through the wind, through movement, so that there will be in trouble? So that question there, we're still evaluating as part of our research. So the soil project, as I mentioned, we went to 4 different properties in Northern Territory because they had different climates, different soil composition, and also different levels of when they were placed under quarantine. So soil samples were collected at the beginning of the project, where they were 8 to 12 months without cucurbit hosts. Soil was collected, taken back to Berrima Farm to do some pot trials, and then we planted cucurbit plants back into the ground to see if in the ground the virus is still there and still alive. We placed, confined that area using insect-free mesh. It was supposed to be bee-free. It wasn't bee-free because we had lots of pollination inside. Yeah, that too. So that we left it there for 2 months. We went back and we tested it. Same scenario. We collected the soil from that, put it into pots, and then planted individual cucurbit plants into each of those pots. And each of them we damaged the roots to ensure that if the virus is in that soil, it's going to contaminate that seedling. So what we found is that at 0 month beginning of the project, the field trial showed that a couple of our properties were still infected with the virus. The pot trial results gave different results. Why is that? That's where the question, we actually have more questions come out from our research than answers. So is it because when we put it into a pot, it's concentrated amount, the virus has nowhere to spread because the soil is compacted, so the virus could be still concentrating and able to infect the plant itself. So at the 6 month mark, quarantine was then lifted. We were unfortunately banned from 2 of our properties that we were doing research on, so we've only been able to identify and work with two properties only. And again, they're still positive. So the take-home message from this is that even after 8 to 12 months after the cucurbits were removed, the virus was still there and it's still viable and able to infect. So this gives us an indication that two years ban of quarantine is actually correct, because even after 1 year, the virus is still there. But normally you would have to have 2 years of no infection to be called the area of freedom. So I guess for Queensland, if you want to go along the lines of area of freedom because your infected areas are consolidated and quite isolated, you may have to consider going up to 3 years. But it's good to monitor things as you go along, because 2 years may be enough, but you might have to go up to 3 years. In the US, they know that 2 years is the minimum. They've got to the extreme of a 3-year ban on growing big peppers. So then we have the National Funded Project. Again, our industry, your levy money is paying for this project, where the key research areas or the 3 key activities or questions that you raised from your industry was that, again, what does the role of weeds play in all of this? Can the seeds transmit? Can we identify some non-host plants that infected growers can use as an alternative to go back to production? What role do honeybees play in disease spread? They wanted us to improve the diagnostics in the field so that we get a quicker answer instead of taking everything back to the lab. So the idea is that we'll go out and investigate several measures or technologies out there. Dipsticks, as you may have known from dipsticks, you can actually get a sample, get the sat and do a dipstick like you do oil checking. Yes or no, positive or negative answer. So all of those will be investigated as part of the project, but we also want to develop a different test. And a part of the next part, which is the important part, is that the extension that I have with Greg, is that whatever we find, we pass on and we disseminate to you. This is the information from the research. What do you think? Does it make sense? And some feedback from our growers. What else needs to be done? How can we relate back to that, linking that information from research to growers? Because this is your levy money paying for this research. So honeybees, what roles do they play? They're used as pollinators commercially. In the Northern Territory, the hives are used on multiple properties, but is it able to transmit the virus or move the virus around? Because bees are classed under the Biosecurity Act for animals, not for plants. So during the time of the emergency pest eradication, restrictions were made on plants but not on bees because they were classed as an animal. So the little bit of research was conducted on identifying 6 infected properties. 3 apiaries were tested. No CGMMV was found in the Darwin area. In Catherine, on the other hand, we had 20 properties. 5 apiaries were tested, and they were found to have CGMMV. So basically, every single product you can find in a bee hive was tested for CGMMV. So you're looking at bee pollen, honey, wax, bee, adult bees, and brood. And out of all of them, we found positive CGMMV in all of those bee products. So as I mentioned before, they can be positive, but is it really alive? Can it still be infected? Can it still be infected? So then we did those bioassay studies. So for all of those bee products, although they were initially positive for CGMMV, only the pollen, the honey, and the adult bees were found to have infective CGMMV particles. So pollen, yes, because we know it's made of plant material. Honey is because it's preserved, but it has a lot of things happening in there. So yes or no, we're a bit surprised about the honey. Bees you expect because they might be carrying the virus particles on their bodies. So again, more questions from this type of research. Is the transmission from flower bee to flower? Is it flower bee, hive flower? This is still questions that we still want to do some research on. We also want to look at how long, if the virus is introduced into the hive, how long does it actually survive in that hive? And where is it actually coming from? So that's to say that, nice picture one, I had to leave it because my colleague put it together and I promised her I'd use it. So we have 2 field trials already conducted, small field trial, one in Catherine and one in Darwin, where we put our cucurbit plants and expose them to bees. In all of them, only the plant flowers tested positive, and the flower plant didn't test positive at all. So the introduction of the virus is actually from above, so from pollinators. And out of that, we noticed that the CGMMV levels in the beehives is actually increased over time.
Did the fruit test positive later on?
Yes.
So the fruit did test positive?
Yes. We didn't test them all, but we did just random
But
testing.
it didn't go past that through
End of the plant?
No. So this again is a little bit different from have sporadic, sometimes the plant is a mature plant, it's a large one, it can get infected on this leaf, on this vine, that would be positive, this one would be negative. So this one will produce healthy fruit, this one will produce infected fruit. It really depends on when the infection occurred. So the other scenario of what we found in our field trials is because the flowers became positive, where was that CGMMV coming from if the plant was negative? So then we're also testing the pollen. Where did the pollen come from? What species? Is it from the species from outside? Is it coming from weeds from outside? So another piece that we're doing as part of our research, as I mentioned, is that we needed to identify what is the non-host of this virus as an alternative cropping. So we've investigated sweet corn, spring onions, capsicum, okra, and snake beans, as well as sorghum and peanuts. Sorghum and peanuts is currently in a trial now. All those in red trials have been conducted, and we found them to be CGMMV negative. So in the first round of results, we found the host in red as non-host of CGMMV, so as an alternative cropping for our growers. Bruce already mentioned the extension activities as part of the project. And this here is the pamphlets or fact sheets that we hand out to our growers when we have meetings. It's actually also on our website, and I've Bruce kindly printed some of these copies at the back for you. So as we're developing and getting more data, we actually write up fact sheets, update the results. We have 6 monthly reports to HIA as part of our progress of our results, but normally we would disseminate information as part of our stakeholder engagement plan to get information back out to the growers. So we've got just under 2 years left on this project. We have a lot to do. We've got our field wet season trial going on at the moment to identify sorghum could be an alternative cover crop. Peanuts, we need to look at the weeds. Are they playing a role? Do they have seed transmission happening? We continue doing the bee research, testing and identify pollen from the hives. Another bit that we talked about is the soil assay, where we use a BIV's protocol, which is kind of given to us and hasn't published yet. Is that he collects soil samples and he purifies the virus from that soil sample, and he can identify yes or no that soil sample has live infected virus or not. So we're investigating that protocol. Does it work? Will it be a research tool only, or something in the future can be developed into a better diagnostics? I've been asked to look at chemicals as a better way for disinfection. At the moment, we recommend sodium hypochlorite as well as Vercon. But they're two very corrosive pieces of chemicals. But it's necessary to decontaminate, and that's the only way at the moment that we know for sure kills the virus. And continue our engagement with industry and farm biosecurity. So this national project is quite large because we have quite a bit to do. So that just lists my NTU team. And then we also have collaborators from Dennis from Queensland, Paul Campbell. We have Western Australia, Victoria, New South Wales, and Aviv from Israel. So just acknowledging all those who helped us with all this work. We're up to about 4,000 samples now for CGMMV, so it's not something that can be done by yourself. So that's it.
You want to also